In this video, we're going to look at how we can solve harder exponential equations by using logs. So we've dealt with exponential equations before, but they've always been nice exponential equations in the sense that you could always simplify numbers down to the same base. However, it's not always going to be the case. So here we've got some examples. So this is the first one we're going to look at. 3 to the power of x, 2x plus 1 equals 8. So if I want to tackle this, one of the first things I'm going to have to do is to change this equation. It's been written at the moment in exponential form. I need to write it, or I'm going to write it in log form. So I'm going to talk about log to the base 3 of the number 8, and that's going to equal 2x plus 1. And if I now rearrange that, I can get that 2x is going to equal log to the base 3 of 8 minus 1, and x then is going to be a half of this log to base 3 of 8 minus 1. Now, depending if they ask you for an exact answer, which is what we've got here, or whether they want you to get to a certain number of decimal places, we can take the problem further. This would be an exact answer. We could leave it like that. If, however, we need to take it a certain number of decimal places, we're going to have to deal with this log to the base 3 of 8. Of what is that worth? Well, I can always go and rewrite that as being, changing this to log to the base 10. So this is going to be a half log to the base 10 of 8 divided by log to the base 10 of 3 minus 1. Once you've got that in place, all you have to do is reach for your trusty calculator, clear off the screen, and then we can say, right, a half times by log 8 divided by log 3 minus 1, close the brackets and execute. Oh, it doesn't like that because there are two signs over there. Let's just delete that one of those. And there we have it. There we have our answer, 0.446. 0.446, and that's to 3 significant figures. So this is an exact answer. This is to 3 significant figures. Right, what about this one? It looks a bit trickier. And I just want to get some more space in here. There we go. So, what are we going to do with this? Well, because they've both got exponents on them, it's going to be a bit tricky to try and exchange that from exponent form into log form. What we can do, though, is we can take the log of both sides. So I'm going to take the log of 5 to the 2x plus 1 is going to be log of 3 to the x plus 4. Because I have simply one term on the left-hand side and one term on the right-hand side, I can take the log of both sides. What's wrong now? Now, having been able to do that, I'm now going to use those laws of logs that we spoke about in the 2 videos ago. So I can now bring my power down to the front. So this is going to be 2x plus 1 times by log of 5 is going to be x plus 4 times by the log of 3. And if I expand those brackets out, I'm going to get 2x log 5 plus 1 times log of 5 is equal to x log of 3 plus 4 log of 3. Now, these two bits over here are simply numbers. They haven't given us a base, so we're going to be working with base 10. So that's all good. What we can do now with these parts over here is we're going to collect our terms that have x's in them on one side and the numbers on the other side. So this is going to be 2x log 5 minus x log of 3 is going to be 4 log 3 minus log 5. That I'm simply going to keep as it is. I don't need to do anything more with this. Here I can take out x, and I'm going to be left with 2 log 5 minus log 3. That's going to equal 4 log 3 minus log 5. And so x then is going to be 4 log 3 minus log 5. All of that divided by 2 log 5 minus log 3. And having got that in place, we now reach for the calculator. And I just need to be careful here with a fraction, so I'm going to open up a bracket. 4 log 3 minus log 5, close brackets, divided by, open the brackets, 2 log 5 minus log 3, close the brackets, press execute, and 1.31. And so we have a simplified answer there.